3, 2, 1. Lesson 3 on annuities. Okay, so welcome back. So in this video, we're going to talk about the calculation of ordinary simple annuities, in particular present values. So bringing all the payments back to the present value, so right at the start of when the annuity has begun. Now, I want to first illustrate it with an example. I'm not going to do any derivations in this video. For the derivation of the actual formulas, okay, so I'll do that and I'll provide you a link in a few moments, okay, if you want to really see where the formula comes from. Okay, so we had started in lesson 2 with this example, except we were calculating the future value. So for 10 years, we were investing $2,000. So that's what you see there on the screen. So 10 different payments. At the end of each year, we had a return of 9.8% compounded annually. So first thing to notice in here is that your compounding and your payments, so your payments per year is equal to 1 because we are doing it at the end of the year, and our compounding, okay, per year is also 1. So in this case, this becomes a simple annuity with regards to that because those two align. Now again, so ordinary annuity, so that simply means that the payments are at the end of each term, all right? And that's what we have. We have the payments at the end of each year. Now, you may recall that if you wanted to calculate the future value, so bringing all the values back, so if you wanted to do that, you know, you could have brought it back all the way down, okay, so at the end, okay, so we could have done this and calculated our future value, all right, so that would have been it. And in order to do that future value, we had to use the future value formula. So I'm not going to do that again because we've done that in lesson 2. So our goal is, instead of now calculating the future value, is to instead take all of these different payments. Let me now remove this from here. And we want to take all of these payments and actually start bringing them back. Okay, so now we want to bring them back into the present. So we're going to have something like this. So here would be bringing the first payment back. We would have been bringing the second payment back, third payment. So all of these different payments. Okay, so that's better. Okay, and so on. So we're going to bring all of these payments, including this last one, all the way back to the start. All right. Now, if you want to bring all of these payments back, so our focal date is basically the present, which is the start of your entire annuity, so your whole term. Now, of course, you can do it one at a time, which would have been pretty annoying because we have 10 of them. I mean, imagine we had 30. And that was the same problem we ran into with dealing with future values. So with future values, again, we were bringing everything back towards the end, and we definitely didn't want to be doing, 10 different calculations and then adding them up. So what we have done is we have created a formula. All right. So just like for your future values, we have a formula which will bring all the payments back, okay, into the present. And that particular formula, so I'm going to show it to you on the screen. Let me clean this up a little bit. Let me remove this. Okay. And what we have is, this is your present value formula. Where did this come from? All right, so what I'm going to do is I will be creating a video, and I'm going to post a link. So I'll do a link up above there as you're watching this video. If you're interested in seeing where this formula comes from, you can click on that link and then watch it. So in this video, our goal is going to be to use the formula, okay, and then actually calculate the payments. So in this example, okay, let's write all of these things down. I'm going to shift this formula to the side for us. And what we have in terms of the givens, so great, we have our payments and our compounding periods, they align. So that's great. And now what we have is, let's write down all the different givens. So our payment is $2,000. So that's what we have for all of these, 1, 2, 3, 4, 5, and so on. We have our interest, okay, so our interest I is equal to 9.8% compounded annually. Now, if you take that, okay, so annually it would be divided by 1. So in this case, I'm going to just leave it as it is. All right, notice I changed it to a decimal. So that's what we have there. And notice how many payments do we have? We have 10 payments. So this would be 10. And now what we're going to do is we're going to take this information and we're going to substitute it back into this formula. So our overall present value would have been equal to, so our focal date is basically the start. And I'm going to substitute this in. So this is 2,000. All right. Then it's 1 minus 1 plus 0.098, okay, to the negative. This is 10 and divided by, and you're divided by I, which is 0.098. Close my brackets. And now for this type of example, you can use your regular scientific calculator, of course. But like I've used in lesson 2, in terms of your business calculator, I will also create a video with these same examples and then inputting all of these in using a business calculator. So I'll do a little link up above and you will see that up there as well so that you can see it. I strongly encourage all students, if you're going to get into annuities, sure, you can do it on a regular calculator, but as you get into kind of annuities due, and then in particular general annuities, you want to know how to use your business analyst, okay, to calculate and input these so that you get rid of some of the headaches with a scientific calculator. But in any case, I do want to show you, okay, how am I going to put this into a regular calculator. So let's do that here. So what I'm going to do is, okay, so we will calculate, and I can calculate, for instance, this entire thing. So in terms of calculating just the brackets on its own, so let's do that first. All right, so what I have is the following. So in the brackets, I have 1 minus, okay, open bracket, 1 plus 0.098. Okay, so close my bracket, and that is to the exponent of negative 10. So that is in my numerator. All right, so now I can just hit equals. So that's what I get on top. And now that answer I can divide, and I'm going to divide by 0.098. So I'll put that in, and that's what I get there. And now, so that is your entire, so that's this right here. So that was equal to 6.19 dot, dot, dot. And I don't really typically write it because the next item is I just multiply it by 2,000. All right. So with this answer, if I take and I multiply by 2,000, really by the payment, okay, then my overall answer will be, so $12,395, and then round it to the cents, okay, and that's what it would be. All right. So that completes this particular example, and now we know our present value if you're going to be bringing it back. Now, clearly you had 10 payments. So your payments, if you multiplied 2,000 by 10, you would have got 20,000. So notice the present value is much less than that because it's about 12,000. And the reason is because of the fact that you are discounting your payments and you're bringing them back, okay? And you're calculating the present value. The one thing that I should mention to you is when you are calculating, okay, and you're working with this present value formula, so I'm going to just blow this up here. So this term right here, okay, let me highlight it. So this particular term that you have, so this one, okay, that you saw there, that has a name that we can associate it with it, and it's called the discounting factor. Discounting factor of $1. So how does $1 get discounted when you're bringing it back? All right. So that's something that you should kind of know. So this is called the discounting factor. All right. And when you're dealing with the future value in lesson number 2, because we are moving money into the future, then we called it a compounding, right, factor for those payments. So this is the discounting factor because we're bringing it back. So that was our first example that you see, kind of the introduction to calculating present values. So really, it is just identifying what is given to you, making sure that you have, your payments and your compounding, okay, aligning. And once you have that, it's just substituting it into an equation. So let's see another example with this in action. So here is another one. So Terry has to pay off a debt in 24 equal quarterly payments of $300. What is the present value of all the payments if interest is 8% compounded quarterly? Okay, so right away what I notice in here is, notice that we have, so quarterly and your compounding quarterly, so both payments and your compounding terms. So what we have is your payments per year is equal to your compounding per year. Now it is quarterly, so it is 4. Okay, so correct. So that's what we have. So that's how many payments we have within a year and how many compounding periods we have. And now with that, I can just start writing off all the different items. So notice there's 24 equal payments. So N is equal to 24. So that's that. My payments are $300. So my payment is equal to $300. And then they want to know the present value for this. And I am compounding, so it is 8%, so 0.08. It is compounded quarterly, so let's not forget to divide that by 4. And here we have it, so we're going to use again our little formula there. And within that formula, so let me paste it back in here. And what you will have, if you were substituting all of this in and you wanted to find your present value, so now that we have our formula, so we can start plugging everything in, okay, into that formula and then doing our calculations, okay, so let's do that. All right, so notice what I've done, okay, so here I just said 0.08, okay, divided by 4, and that was 0.02. Okay, and now if I substitute everything in, so I have 300, 1 minus, so this will be 1 plus, okay, so 0.02 to the negative 24, and then divided by, and that's 0.02 right there. All right, now let's take out our calculator and see what happens. Okay, so we'll do that right there. And again, take your numerator within your brackets first. So we have 1 minus, open bracket, this is 1 plus 0.02, close bracket, to the exponent of negative 24. So that's what we have there. So that's equal to that. Now you're going to take your answer and you're going to divide by the denominator. So now we're going to have that. So it's about 18.9 and so on. And then finally, don't forget to multiply by your payments. And that will give us 5,674.18 cents. All right, and that would be your present value. Now, again, remember, you're bringing it back, so it should be less than all your payments, right? Because we are discounting these. And so clearly, if we had 24 payments times 300 and there was no interest, it would actually be 7,200, which is more than when you bring it all back. And that's what you want to see, right? Your value for present value should be smaller if you do have a discount, okay? And in this case, it's 8% compounded quarterly. So that's this example, all right? So hopefully that makes sense to you. And let's remove this calculator and try to show you one more example so that you can see this in action, and I encourage you to try it on your own. So this is a neat one. You have a car loan spread over the next 6 years, and you have been dealt with monthly bills of $750. So you have payments to pay. Now, if time value of money is 3.5% compounded monthly, So notice, so right away I noticed that your bills are monthly and you're compounding monthly. So that's one of the first initial things you want to see. You want to make sure that these two are the same if it's an ordinary simple annuity. So now it is monthly, so this would be 12. And now let's take a look and see. All right, so this says it's for 6 years. So N is equal to 6 years times 12, right? Because for 6 years monthly, so that's what it would be. So this would equal to, so this is 72. Now your payments, okay, so your actual payment is equal to $750. And your compounding, so your I, so 0.035 divided by 12. Now in this case, I'm actually not going to simplify this 0.035 divided by 12, because if you do, let's take a look here. It's going to give you an annoying small decimal, okay, so there you go. And you certainly, so what some students do is they do this, and then because of this, as you can see, the 66666, they don't put all of them in, and then your answer is off a little bit. So if I notice that this happens, I just leave, okay, this as a fraction, and I will input into my calculator as a fraction, and you'll see that. So again, in terms of your formula, so here is your present value formula, and now we have, okay, the following. So my payment, so $750. 1 minus 1 plus your I, and this is where you input your I, so 0.035 all over 12, raised to the negative 72, all right, and then divided by your I, and again your I, so I'll put it in brackets here for myself. So it's always nice to put it in brackets when you're substituting in the fraction. And this is what we have. So it's a little bit of a mess. That's why using the business calculators, and I hope that people watch that video so that you can input this and then just get an answer right off. Because when you're using a scientific calculator, so I'm going to just show you, it becomes a little annoying like in the previous cases. Okay, so what do we have? We start with the numerator again. So I'm going to say 1 minus, okay, open bracket, and this is 1 plus. Okay, and this will be 0.035 divided by 12, close bracket. All right, so this is what we have here, and it is to the power of negative 72. And I'm going to hit equals. So it's this in your numerator, and now we're dividing our answer. So divided by, and I'm going to open bracket here, 0.035. and divided by 12, okay, so close bracket. Again, it's nice to keep it in brackets because you're dividing by the entire I. And now if I hit equals, this is what I will get, all right? So that's what I have there. And then I'll take my answer and then multiply it by 750. So I get 48,643.19 cents, all right? And notice in terms of payments, again, you had 72 payments times 750, all right, which would have been 54,000. So again, you want to see the present value to be less. Now it's only 3.5% compounded monthly, so it's not going to be a lot less, although as you can see, the discounted value is quite a bit. All right, so it's a good nice, about 5,500. So this finishes these examples and hopefully introduces you to the present value of annuities. And again, it's just bringing money back. All right. So thanks for watching, and we'll see you in the future videos. All right. Okay. Peace, everybody. Cheers.